Two cars are both initially travelling at 10 metres per second. Vehicle A travels from left to right. So this is vehicle A. And vehicle B travels right to left. They collide head-on and lock together. Immediately afterwards, the combined wreckage travels left at 4 metres per second. Vehicle A weighs 1,500 kilos. Both travelling at 10 metres per second. Okay, 10 metres per second. 10 metres per second. Calculate the impulse. Alright. So, the impulse of A on B is going to be equal and opposite to the impulse of B on A. That is the nature of these collisions. So, impulse is equal to change in momentum. And change in momentum is equal to mass times change in velocity. So what we're talking about is mass times by final minus initial. And so we can work out the impulse or the change in momentum of A. So that mass of A is 1,500. Its final velocity is 4 metres per second. And I will take this direction as a negative and that direction as positive. It doesn't matter what you choose as long as you're consistent. So therefore its final is minus 4 and its initial is 10. So we've got 1,500 times by minus 4 minus 10 is minus 14. And so 1,500 times by 14 negative is minus 21,000 kilogram meters per second, or Newton seconds. Minus 21,000 is telling us it's in this direction. Okay. Calculate the vehicle impulse by vehicle A on vehicle B. Okay. All right. So the impulse by vehicle A on B. So we determined the impulse on A, not by A. So the impulse that vehicle A exerts on vehicle B, well, vehicle B is slowed down, so we know that the impulse is going to be this way. So it's 21,000. Okay, using your answer to question 6, estimate the average force acting on vehicle B if the duration of the collision was that. Okay, so our net force, or the average force, is equal to the change in momentum divided by the change in time. We've already worked out the change in momentum. It's 21,000, and the change of time has just been given to us at 0.25. So therefore the answer is 84,000 newtons is the average force, or the net force. Question 8, determine the mass of vehicle B. Alright, so M1U1 plus M2U2 is equal to M1V1 plus M2V2. Okay, the initial velocity on the before side, final velocity on the after side. Okay, so for vehicle A, before the collision, we've got a 1,500 kilogram car doing 10 meters per second plus, let's do brackets here, M2, which we don't know the mass of this car yet, times by 10 meters per second in the opposite direction, so that makes it minus 10, equals 1,500 times by minus 4, keeping our directions consistent, plus M2 times by minus 4 as well. 1,500 times 10 is 15,000, plus minus 10 m2 equals 1500 times by minus 4 is minus 6000 plus, I'll just put some brackets around this, plus minus 4 m2. Okay, let's add 6000 to both sides. So that gives us 21,000 minus 10 m2 equals minus 4 m2. We add 10 m2 to both sides, we have 21,000 minus 4 plus 10 is positive 6 m2, and we divide both sides by 6, 6 cancels out, 21,000 divided by 6 gives us m2 being 3,500 kilograms. Question 9, is the collision elastic or inelastic? Okay, so we need to work out the kinetic energy before and compare it with the kinetic energy after. So the kinetic energy before, we've got two things travelling, half mv squared of vehicle A plus a half mv squared of vehicle B. So vehicle A was 1500 kilograms times by 10 metres per second squared plus half times by 3,500, we'll just work that out, times by minus 10 squared. Half times 1500 is 750, oops, times by 10 squared is 100, and plus 3,500 times by a half times by minus 10 squared is plus 100, so this minus disappears on us, 175,000, 750, 750, and add 2 zeros, which is 75,000 plus 175,000 equals 250,000 joules. That's our energy before. Afterwards, our kinetic energy is half mv squared. Two objects have locked together, so it's a half times by the masses, which is that plus that, so 3.5 and 1500 is 5,000 kilograms, times by minus 4 squared. So 4 squared is 16, and minus 4 times by minus 4 is positive 16, times by 5,000 times by 0.5 equals 40,000. 40,000 joules, and clearly we can see that these two, it has lost 210,000 joules. That 250 is not equal to 40,000 joules, therefore the collision is inelastic.